Hi guys, welcome back to Maths is Easy and Fun class. And today we are going to talk about algebra. We're going to talk about algebra. Algebra is broad, okay? So as we move on, you know the topic areas we'll be taking, okay? So don't worry. And algebra is actually talking about the unknowns, because that is where we see the x's and the y's, and so we are going to handle that. And so we'll be doing learning about terms, we'll be learning about variables, we'll be learning about factorization, quadratic equations, change of subject, and other stuff that come with the x's and the y's and things like that. So please just relax, take it easy and follow the class, because algebra is one of the very tough areas, okay, that we struggle with when it comes to math. So we are going to take them very easy. We'll take them from the scratch till you get so strong in working algebra. So let's first start with our first thing. Let's know what variables are and on. Okay, so talking about algebra. Algebra, like I said earlier on, it's about the world of unknowns. So you work with unknowns. So that is where a lot of letters, variables come in. So we are going to take our time to break down some of these terms. So algebra is actually like the sentence structure, or what can you call it, how you write things with unknowns, especially in maths, how you can read maths writing. Okay, you can read maths and understand what you are reading, and you can change it into the basic ones, the basic fundamental maths that we use. So please, let's follow and see how this goes. So for us to really understand what algebra is, we need to understand some very basic structure or terms in algebra. And one of the terms that we'll find a lot is a variable. A variable, as the name suggests, something that varies. So when there is an unknown quantity, you represent it with a letter, a word, or a symbol. Okay, so that is a variable. It means you don't know the real quantity, and so you put something there that it could be a different number. Okay, so that is what a variable is. Now we can have expressions. An expression is kind of a sentence in math, but incomplete one. Okay, so just as in English we have a phrase, or what do you call it, an incomplete clause. Okay, a sentence is just when someone speaks in math and the person has not finished. So 4 is actually an expression. 4x is an expression. 4y plus 3 is an expression. Okay, so that is it. But when we come to equations or inequality, that is when we speak complete. We give a complete sentence. So an equation or inequality in math is a complete sentence. It's a complete sentence, and before it will be complete, then it contains one of these symbols, either equal to, less than, greater than, less than or equal to, or greater than or equal to. You get that? So that is what it means. So when you see 4x is greater than 8, you know you've said something completely. So it's an inequality, and it's a complete sentence in maths. When you see 4y plus 3 equals to x, it's also a complete sentence, which is an equation. Okay, an inequality is when we are not sure it's greater than, so it's not one number. Okay, but equation is when you are sure, but they all form complete sentences. They give a clear meaning of what they are saying. If 4x is greater than 8, 4x is greater than 8. That is it. It's a complete sentence. The same way 4y plus 3 is equal to x. It's a complete sentence as well. So as we move on, this is what we'll be seeing. Okay, so let's get ready for it, and we go to our next terms that we'll explain in variables. Sorry, in algebra that we'll be using as we move along. So just follow the class. Yes, so as we talked about sentence in algebra, we understood that it's a complete equation, but even in a sentence or an expression, or in other words, when we use phrase, we have words. So when you say a term is actually a word, or the words that you found in expressions, equations, or inequalities. They are the words. So word as in English language, but in maths they are called terms. Okay, so they are called terms. A term can be a single number on its own, a term can be a variable on its own, or a term can be a product of a number and a variable or variables. A term can also be the quotient of a number and variable or variables. You need to know them. We'll see examples. So a term is actually something that is separated by a plus or a minus. But if it's multiplying, it's a term on its own. Okay. So we'll see examples. And now our notes here says that we should take note that the sum or difference between a number and a variable is not a term. Example, 5 plus x is not a single term, but 5x is a term. 5 plus x is not a single term. So we have two terms here. With 5 and x, we have 5 as a term and x as a term. But 5x is a term. So let's get the difference. So 5x is a word on its own, but 5 plus x is not a word on its own. There are two words. So it is actually an expression that we have here. Okay. In an equation or in an expression, terms can be identified by separating them with a plus or minus sign. So you can identify terms when they are separated with the addition or subtraction sign. Okay, so let's get it so that we don't confuse things. Okay, now we've talked about terms. Let's think about like terms. What are like terms? What are like terms? Like terms are terms that contain the same variables in their same powers. Forget the number attached to it. That is the coefficient of that term. But what we are saying is the variables must be the same. The powers on each of the variables that are present must be the same. The variables must be the same. The powers on the variable must also be the same. So 5xy and 25xy are terms. They are like terms. 5xy and 25xy are like terms because xy and we still have xy here. It doesn't matter what numbers are attached to them. The variables, that are the letters that are used, must be the same. Does that make sense? The letters must be the same letters and they must have the same power or index or exponent. So from what we see here, x, y for the first one, the second one too is the same x, y. Although the number changes 5 and 25, that is no problem. Okay, so that is it. So we'll continue with our definitions. And when you get these basics very well, algebra will be very easy for you because we'll be building on these basics as we move on. So after talking about like terms, we will talk about unlike terms. Unlike terms, it means that they are not like terms. How do you know if two terms are unlike terms? They may contain the same number of variables, but they may not have the same powers on each variable. Okay, or it may be only a couple of variables they have together. Okay, so when the variables are not the same, and the powers on the variables are not the same. So the two conditions must be met before they are terms. If those two conditions, the first condition is they must contain the same variables on each term, and also the variables must carry, each variable must carry the same exponent, okay, or must have the same exponent, otherwise they are unlike terms. Okay, so example here, 5xy and 25x squared y. Because the x in the second term is squared, whereas in the first term it is not squared, it's just exponent 1, the terms are not like terms, so we call them unlike terms. Okay, so that is what we need to know. Now, operations on terms. In like terms, you can add them, you can subtract them, you can multiply them, and you can divide them if they have common factors between the numerator and the denominator. That is when you are doing division. So like terms, it means that terms that have the same variables and the same the same exponents, you can just add them, you can subtract between them, you can multiply them, and you can actually divide them if the terms are the same, if they are like terms. Okay, unlike terms can only multiply or divide if there are common factors. So they can multiply, it doesn't matter if they are common factors, but divide, they must have common factors to be able to divide. That is unlike terms. Okay, so let's get it. You cannot add unlike terms. You cannot subtract between unlike terms. You cannot do that. Okay, so the example we have here, 5xy maybe plus 25x squared y. We leave it like that. So we leave the expression like that. We can't do anything to it because they are not like terms. Okay, they are not like terms. So let's see as we move on how we can be applying these things. So this is an example of algebraic expression. So we are coming to do addition and subtractions. Remember, we were told that if they are not like terms, meaning that if they don't have the same variable and the same powers on the variable, you cannot add or subtract them. So we are only going to bring terms that have the same or like terms together, and we can solve them. So from here we can see that this 22x, we go through, does it have any term again? Yes, we have minus 7x to another term, so these terms can work together. So 22x minus 7x, remember that the sign must go with the number after it. Okay, then we see minus 4xy, we write it down, but we see plus 3xy, so plus 3xy. So you can see that these are terms as well. This one are terms, so these ones are terms, and these two are terms. So you can add or subtract between terms. So here we'll be getting 22x minus 7x, which gives us what? 15x. Then minus 4xy, you know that it's xy, and yet we have xy. Okay, don't worry about the coefficient. The coefficient is actually the number multiplying any variables. Okay, so minus 4xy plus 3xy will give us minus xy. Or how you treat it is, if they have the same term, you can give it a name. So xy, you can say that maybe is a shortened form of xylophone. So minus 4 xylophone plus 3 xylophone. It will be left with negative xylophone or negative 1. Normally we don't write the 1 when the coefficient is 1. But if you like, you can write it. That is fine, if that is how you can get to understand this. Let's get this well. when we are adding or subtracting, group terms together, move one term to the other, let them come to the same place. The signs will not change because there is no equal to sign or an inequality sign. Okay, so when it's between the same expression, move it with the sign. So here we have 22x and it has a like term with negative 7x, so you bring them together. So 22x minus 7x, you bring it together, then you are left with minus 4xy plus 3xy. So you write them down. Because xy and xy are the same term, you have a single thing to work with. So all you have to do is just work between the numbers and put the variables down. So this is our answer. Now we have 15x minus xy. There are different terms. They are not the same terms, so you leave them as they are. You don't do anything to them. It's left. This is simplified to its lowest form that you cannot do anything about again. Now let's get to the one on our right. We have how many terms? 1, 2, 3, 4, 5 terms. 5 terms, but it's an expression. So it's just a phrase with words in them. So we are now coming to identify. You can see I counted 1, 2, 3, 4, 5 because they are separated by a minus, a plus, a minus, a minus. Okay, so they are now individual terms. Okay, now let's see the like terms among them. 14y. So we are looking for anywhere there is only y, 2y, and negative 5y. They are the same term. So what we are going to do is we bring them out. 14y plus 2y minus 5y. Okay, so we are done with the y. Let's take another color to see. Minus 6x. Is there any x? Oh, minus x, sorry. Let me write the x first because it comes before the 6. Minus x. Okay. Then we are looking for, because now the term here is x term. And it's minus 6x, so they are also in the same term. That's why we are using the same color, minus 6x. So now we are going to simplify. Because we can add or subtract terms, the terms here is 14y plus 2y. Write your y down, which is your the variable attached to the term. Then it's only 14 plus 2 minus 5. So 14 plus 2 is 16. 16 minus 5 is what? 11. Okay. The same way here, because they are minus, you are definitely going to get a minus. And write your x down because that is the variable in the term, the only variable. So it is now 1 minus 1 minus 6 because this has a coefficient of 1. Any variable without a number multiplying it is multiplied by 1. So it is 1x and 6x. So it will be what? 7 minus 7x. We cannot do anything to them because the term here is different from the term here. So this is simplified to its lowest form. Okay. Okay, let's move on. Yes, we are still on addition and subtraction of algebraic expressions. Okay, so let's see how it moves on again. Now, what did we say we'll do first? We'll look out for common terms or like terms. Okay, so first of all, we look at the n side. The n is 2n. We go through, we see another negative n. So it is 2n minus n. Okay, so we are done with that term. We are going to, that term, which are like terms. Then we come to m, so plus m, just write it down, the next number. Then look for another m is here, plus 9m, then plus minus 2m. So we are lucky there are only 2 different terms. So these terms will work on their own, this one's too will work. So like I said, since it's n, write your n down. So it is now 2 minus 1. Remember, when the variable is not multiplying anything, that number is 1. So it is 2 minus 1. So it is 1n. But you don't write 1n. It is n. So you leave it like that. Then you finish this before you know the sign you have to put down. So m which is 1, plus, so you write your m down, okay, because that is the variable multiplying the variable for that term. So it is 1 plus 9, which is 10. 10 minus 2, which is 8. So it is plus 8m. So this is your answer. Okay, let's go to the next one on our right, the top one. We can see here we have only it's one term throughout, so it is easy. So we just write our m down because m is the variable represented in the term. So 16 minus 15 is 1 plus 3. It is what? 16 minus 15, 1. 1 plus 3 is what? 4. So it is 4m. Okay, so you are just going to add the numbers or subtract the numbers attached to the variable. Just put the variable down and work on the numbers only. Okay, so we come to the last one, which we see two different terms. We see a term in k and a term in k squared. But the term in k, we have 20k and what? 6k. So write your k down. And see, 20 minus 6 is what? 14. Then here is plus k squared because it is k squared. This is k and this is k squared. They are different. Remember, we said a term must have the same variables and the same powers. Okay, so we move on. Okay, so now we come to multiplication and division of algebraic expressions. Okay, multiplication and division of algebraic expressions. And this one, it doesn't matter what terms. Like we said, multiplication and division you can do for any terms. Okay, so all you are going to do with this is you are going to first multiply. When you are doing multiplication of terms, you multiply the numbers, that's the coefficients, together. Okay, so we are going to get 4 times 8. Okay, you multiply the coefficients, then you multiply the variables too. So 4 times 8 by another p times p squared. Okay, so you are going to get 4 8 what? 32. Then p times p squared will be what? P cubed. Okay, this is what we did in our indices, so you can do this. Okay, so that is for the first one. The second one will do the same thing, and numbers will multiply numbers. So 4 5, we have 20. Then x is there, x is here, so x times x raised to the power 4 will get x raised to the power 5. Okay, let me use a different marker here so that I underline this. Then we'll use a different one here to indicate y squared and y cubed. We are going to get y raised to the power, so y squared and y cubed. We are going to get y raised to the power what? 5. Okay, you know your indices, so please go and listen to the indices video and you understand why we are doing this. So you are going to get the numbers multiplying themselves. 4 times 5 times 4, okay, will give us 20. Then x times the x raised to the power 4, because we need to get the same base. So x and x will get x raised to the power 5, and y squared, y cubed will give you y raised to the power 5 as well. So that is your answer. Let's go here. Numbers become 3 here. So it is -2 times 4 times 5. So you just, it's because it's only one negative. Let's drop it, finish multiplying, and just put the negative sign there. Or let's put the negative because the resulting answer will be a negative. 2 times 4 is 8. 8, 5, 40. Okay, so we get our 40 here. So 2, because it's multiplying, we'll multiply the numbers. Then we'll come to the letters too. It is only A, B, C. So we just put our A times B times C. Okay, so that is our answer for this particular one. Now we come down here where we have 15y cubed divided by 3y squared. Okay, so all we are going to do for division, if I were you, I'll just write it in the form that it will be easier for me. So I'll write my 15y cubed divided by 3y squared. Please, you can go and check the video on indices, because this y are the same y with what with the same base. Okay, same base. So what you do is you subtract between the indexes. So when you subtract, you are going to get 15 or 3 going to 15, 5, and y squared will go into y will be this y. Okay, y raised to the power 1, which is y raised to the power 3 minus 2. Don't worry about that for now. Go and take our indices lesson. It's on our YouTube channel, so you need to go and listen to it, and you will know that you know how we went about this. Okay, now we have 16 a cubed b squared divided by 2ab. Okay, 2 will go into 16 how many times? 8 times. 2, 8, 16. Then a can only divide a cannot divide b, so a cubed divided by a will be a squared, and b squared divided by b will be what? B. Okay, so that is it. Very simple. Just take your time and do them step by step. Don't rush it. It's not worth rushing. Take your time and do them step by step, and you realize that you can work plenty even harder questions. Sorry. Okay, so we had a few examples of simplifying algebraic expressions. Now we've turned them into equations or inequalities. Okay, so please, the same way you did them, just that this time around there is an equation sign which is the equal to, or the inequality sign which we'll be having in later examples that will be working. So please don't rush it. Take your time. Whatever you did is the same thing. You do the same thing, but this time around some numbers will be moving to the other side. Okay, from what we see here, the instruction says that find the value of x for the following. So it means that we are making x the subject. We'll be treating change of subject on its own very soon. This time we are dealing with only one variable equation, meaning that only one variable is there, which is the x. That is why we'll make it simple. So now, this is the caution I'm going to give you from the beginning, and you have to take this serious throughout. Anytime you are making something the subject, or you are finding any variable, make sure you move all the smaller ones to where the bigger ones are. Listen carefully. Move the smaller one to where the side where the bigger ones are. So if the bigger one or the big one is on the left hand side of the equation sign or inequality sign, move it there. It doesn't matter where it is. Please, I am telling you this because when you start working in equalities, what will happen is sometime after working, you may want to divide through with a negative sign. And when you divide any inequality with a negative, the sign changes. A less than sign will change into greater than sign. They will not change by themselves. You must do the changing. So if you forget, and as human beings under pressure, when we are being beaten by time, when the question has kind of shook our ground a little bit, we get so confused and we may forget that, and that gives us a wrong answer. Because if you say if I'm older than you and you say you are older than me, it's never true. It can't happen. It's not acceptable. Okay, if your money is greater than $1,000 or 1,000 Ghana cedis and somebody says it is less than that, in fact it can generate into something unpleasant. So you don't want to make that mistake. So for you to avoid that, move the smaller one to where the bigger ones are. Okay, so if you like, just simplify the expressions on each side. Make sure you've simplified them, added all like terms, subtracted all like terms on each side on their own. Then you know the resulting terms, okay, especially the one you are making the subject. Okay, you will now know that it is smaller here or it is smaller there, and move the smaller one to where the bigger one is. Okay, so that you don't have to divide anything through by a negative number, which in equation you are fine, but in inequality the sign must change. Okay, but we'll work examples and you see. So let's continue with this. From what I said, we are making x the subject, so x, the terms in x are here. Okay, one is 4x, one is negative x, negative 6x, sorry. Negative 6x is smaller than the positive, so you rather have to move the negative to the left hand side of the equation. So this one should move to this side. The 4x will be there, it's not moving. Okay, so first of all we'll do that. So there are two ways of moving this. It's either you move it by yourself in your head, you know. So you write your 4x. Then when you move this, it becomes plus 6x. Remember, when you are moving something from one side of a number, from one side of the equal to sign to the other side, the sign changes. Okay, and there is a reason for that. The reason is that it is something we call additive inverse. So when you have 6 and minus 6, when you add the two, you get 0. Okay, so here what we wanted to do is we want to get rid of this x here, so we added a 6x here and we did the same thing, 6x here. Okay, so you find the additive inverse of the number and add together. So minus 6x plus 6x is 0, but since you did for the right hand side, you have to do for the left hand side. Okay, that is the reason why. So but in simple terms, we'll say that we are moving the 6x to come here. When we move it, that one we don't have to do to both sides because we are just moving it. When you move it, it becomes a positive here. Then you have your minus 5 written down nicely. Here there is a 10 here. Okay, we still have realized that, okay, let's do our like terms. We're going to have 10x minus 5 equals to 10. We are only looking for x, so we have to move everything. Just like I told you, it's either you move this 5 here and you say that you add 5 to both sides. Because what you do for the left hand side, you do for the right hand side. There should be fairness everywhere, even in math. Okay, so but the easy way is we are moving it, it is going. So as you move it, it becomes what? A plus. So you get 10x equals to what? 10 plus 5, right? So your 10x equals to what? 15. Okay, you still want x to stand alone because it's being multiplied by 10. You divide through by 10. What you do for this side, you do. So 10 will cancel. So your x equals to 15 over 10. Okay, which is an improper fraction, but fraction is another thing we'll come to. So it says find x, so x is 15 over 10. So let's take care of the one on the right hand side. Okay, we have an expression here and another expression on the other side. The expressions are in their simplest form because you can't do anything. This time around, we've just met the issue where the bigger x value is on the right hand side. So like I told you, please don't bring it here. It will leave you with a negative sign that you need to be dividing through by negative. And we can forget. Negative sign, when you are dividing by negative, you can forget it. Or even when the sign becomes a greater than or less than an inequality sign, you may make a mistake or forget to change the sign after dividing. It will not change automatically. Okay, so you need to know how to do this by yourself. So rather, to avoid any problem, I'll keep the 14x here and I'll bring the 8x. It's a positive 8x, so you move it and it becomes a positive 8x. minus 3. Let the minus 3 be there, and there's still the 15 here. You've not done anything to it. So now, if you like, even before you do, you can bring the 3, because that one there is no x to it. So 15, it is minus 3. So when it's coming to become a plus 3, and this one will be 14x minus 8x. Sorry, I made a mistake. I knew you saw it, but I couldn't say. Oh, you said it, but I could not hear you. So it is a positive, so it becomes a negative. Okay, it becomes a negative 8x here. Sorry, it's a positive that moved, becomes a negative. So we get 14x minus 8x. Like we said, write your x down. Okay, then it's 14 minus 8. So forget the x's there, put the variable down, then just work between the coefficients. So 14 minus 8 is what? Is it 6? Yes, it's 6. So we get 6x. Then we do our normal algebra, which we get 18 here. Normal arithmetic. 18 equals to what? 6x. We divide through by 6. Okay, so 6 cancel 6, and we get x equals to 18 over 6, which is what? 3. So you can still write it this way after finishing, because the same thing is equal to sign. It doesn't matter which one comes first. To avoid any traps of negatives, please always move after simplifying expressions on both sides and combining and adding and subtracting like terms, then you now know the resulting terms. And the term that you are making the subject, you know which one is bigger than the other one. And it's easy to now move the smaller one to where the bigger one is, so that you never work with negative or dividing through by a negative number. I don't want you to go there at all. It is too dangerous. It saves you some steps and also the risk of falling into forgetting a negative division or anything. Okay, so let's get that well. Okay, so let's go to our next one. This time around we can see inequality signs there. Please, it's only the sign that is there, and we've taken care of the trap, so we don't have any problem. We are just solving it like equation. Okay, the trap was where when you have to divide through by a negative sign, the sign must change. Okay, that is the inequality sign. Either the greater than, the less than, greater than or equal to, or less than or equal to sign will be changing. That is the only thing that makes a change in the working. Otherwise, everything is worked the same. So you don't need to waste any time. Do the same thing as if you are working for equation. Okay, check expressions on the left hand side and expressions on the right hand side. Simplify them as we worked on the simplifying expression. Follow the same method, and after you've simplified them and nothing can be done, you can continue moving what you need to move. Here is simplified. 16 plus 5x is simplified. That's the left hand side. On the right hand side we have only 6x, so you don't have anything to worry about. Okay, so all you have to do is to move the x, but you can see that there's 5x here, which is 5x, positive 5x, which is smaller than the 6x. To avoid the trap or problem or any temptation of leaving negatives, I would rather move the 5 to where the 6 is, because the 5 is smaller than the 6. So you are going to get a positive result at the end of the day. So you wouldn't have any reason to be remembering how to divide through by a negative and change signs. Okay, so this leaves here with 16. Keep your symbol like that. Don't do anything to it. Just write it the way it is. 6x is already here as positive, then minus 5x. Okay, so you get your 16 is greater than or equal to what? It's greater than or equal to what? X, because you bring the x down. 6 minus 5 is 1, so x. Okay, so if you want to rewrite this, that one you are rewriting it, so you can write your x. It is like this. But you can leave it this way, it's correct. Nevertheless, if you want to feel comfortable writing it, it's the same thing. The x is on the smaller side of the sign. Okay, It's the same thing. Otherwise, leave it this way and any teacher will mark you right. You don't have any problem. X, if you are reading, is the same as x is less than or equal to 16, or 16 is greater than or equal to x. It is correct. If you did not do it so, this is the temptation you will find yourself in. Let's quickly do that as well so that we'll see. You will bring in this here, so you will get 5x minus. Okay, let me work it while we'll clean it so that we'll have space for the second one. So let's take it that you'll be working it the way we've been working all the time. We always move everything to the left-hand side, which we may fall into temptation sometimes, not all the times. So we'll have 5x, because we are moving it to the left-hand side, it's minus 6x. Then we'll keep our sign greater than or equal to minus 16, because we move the 16 to the other side. So we move this 6x to the left hand side, and we'll move the 16 to the. So you see that this is what you did. You'll be getting negative x is greater than or equal to negative 16. You are looking for x, not negative x. So you have to divide through by negative 1, divide through by negative 1. Okay, yes, you can forget and say, yes, I've divided. Negative will cancel negative. Here too, negative will cancel negative. You have to change this sign. You have to change the direction because you divided through by a negative. So it must be this. But you see, the job of doing that kind of thing, you may forget. You may just write it the way you see it and move on. But it will be wrong. X should be less than or equal to 16, not greater than or equal to 16. But the moment you cancel out, the sign must change. Cancel with a negative number, the sign must change. You don't want to enter into such temptation, okay? So rather move all the smaller x's to where the bigger x's are, or whatever you are making the subject, move the smaller numbers to where the bigger numbers are so that you don't struggle with working. Okay, and that is what you are supposed to do. Okay, so let's get rid of this and solve the other one. So we don't want this. That's why I'm even cleaning it. That's not a good idea at all. Okay, stay away from trouble. Okay, now let's solve this. We can see the symbol here is what? Less than. Nevertheless, like I said, you are just solving it like you're solving equation. The only difference is changing of sign when you have to divide the final answer with a negative number. But from what we've learned, we are not going to do that. Okay, so we are fine. So treat this. So check on the right hand side, keep your sign there. Check right hand side, simplify everything. Here it is already simplified. So we have 12x plus 20. And here we can see that we have 22x plus 2x. It will give us 24x, okay, minus 16. We are not changing anything. We just added or simplify like terms. Okay, so we have 12x and 24x. 24x is bigger than 12, so we'll just move the 12 to the right hand side. We'll just move the 12 to the right hand side. So this will be 24x will stand here. The 12x is a plus 12, so we'll move it. It becomes minus 12x. Then we have minus 16. Then we have our 20 standing here. The 20, nothing happened to it, so the 20 will still be there. Then keep your sign. You are not changing sign. So your 20 is here. The 16 will move to this side. It is negative 16, so it will become a positive 16. And we told you the reason why earlier on. Okay, but we have 24 because the variable is x. Put the x down. So it's now 24 minus 12, which will be what? 12. So we'll get 36 here. It's less than 12x. You divide through by 12. Divide through by 12, both sides. You get x equals to x is greater than what? 12 into 36 is what? 3. So x is greater than, it's just what we saw here, is greater than 3, or 3 was rather less than x. Is the same thing, just that don't change the positions. Make sure that if x is at the bigger end of the sign, you put it at the bigger end, that is the opened end. Okay, so let's move on. Okay, so we now move to binomial expressions. We've already learned about expressions. We know expressions are terms that have been separated by a plus or minus signs. Binomial expressions are expressions with exactly two terms. The name binomial, it means that it's an expression with only two terms. So we're going to learn how to work with binomial expressions, that is expressions with only two terms. Okay, so now examples: 4 plus y is a binomial expression. 2x minus z is a binomial expression. X plus y is a binomial expression, etc. Okay, so now we are doing addition and subtraction of binomial expression. Okay, so addition and subtraction, all we are going to do is to add like terms and leave the resulting terms for a new expression which may not necessarily be binomial. So here they are in bracket because they come as a group, so be careful when you are opening up brackets. Okay, so here it is 2x plus y plus everything here, so it is still plus x plus 4y. Okay, so you can see that now we have two different terms, the x terms and the y terms. So do the x terms: 2x plus x plus y plus 4y. Okay, so because they are in the x terms, you just put your x down. 2 plus 1 is 3, so 3x. Then this one 2 plus, because they are in the y terms, put the y down. 1 plus 4 is 5, so this is your answer for the first one. Let's check out this one. This first parenthesis will be like this: 4x plus 2y, but it is minus everything inside though. So it is not minusing only the first number, it's minusing everything inside. So it is minus 2x minus y. Okay, let's bear that in mind. Please don't just give it because it's this is an expression on its own. This one here is a complete expression. That is why it's in a bracket. So far as it's in a parenthesis or a bracket, it means that it is treated as one number. So the negative is affecting everything inside. Is that clear? It's a bit confusing, but take it easy. Here it was positive, that's why we didn't have any problem. But here it is negative, so it is minus each individual term in the expression because of the parenthesis that was brought. Okay, there was parenthesis. If there was no parenthesis, then it's affecting only the number that is closest to. But when there is parenthesis, it means that it's affecting everything here. So it's saying that minus 2x and minus y. So it's minus 2x minus y, because inside the parenthesis is minus y. But minus will be positive. So we are going to get 4x plus 2y minus 2x plus 4 plus y. Sorry, do we get that? Now we can see the terms. We have 4x and minus 2x, they are in the same terms, and we have plus 2y plus plus 2y plus y, they are also in a single term. So when we take this term, it is x, write the x down, it is 4 minus 2 and we get 2. Here the second term is y, so write your y, and it is what? 2 plus 1, which is plus 3. Do we get that? As simple as that. It is confusing, but take your time, relax, do them step by step. Do not rush it, and forgive my pen. It's a free handwriting, so just have fun with it. Okay. So we just did addition and subtraction of binomial expressions. Now we are going to do multiplication of binomial expressions. We are going to do multiplication of binomial expressions. So this is how we do it. Okay, it is very easy. One way you can do that is what we call the FOIL method. The FOIL method, you multiply first terms. Okay, so there are two binomial expressions multiplying themselves. Okay, so there is a first and a second number in the first and last and first and last. Okay, first and last. So a is the first here and 2 is the last in the first binomial expression. Then a again, another a is the first and 3 is the last. So you are going to make FOIL. The FOIL stands for first terms will multiply themselves. So first terms will multiply themselves. Okay, first. Then O stands for outer terms. So outer terms, this is also an outer term. You see outer, this is the outer left and this is the outer right. Okay, so outer terms will also multiply themselves. Then inner terms will multiply themselves. These are the inner terms will multiply themselves. Then last terms will multiply themselves. This is the last term in the first binomial expression, and this is also the last term in the second binomial expression. So it's as simple as that. Okay, so this is the FOIL method. FOIL standing for first terms multiplying themselves. So we're going to have a times a. We are done with that. Then what again? Outer terms, a times 3, right? So plus a times 3. Okay, so we have that. Then we come to inner terms, 2 and a. So plus 2 times a. Okay, then plus the last terms, 2 times 3. Please, we'll be using this later on, so you need to pay attention to that. Okay, we'll be using them later on. The FOIL method, we'll be using it to do some magical things as we move on, and you will love it. So you need to get this concept very well. Is that clear? Okay, that is nice. So a times a will give us a squared. A times 3 will give us 3a. 2 times a will give us what? 2a. And 2 times 3 will give us what? 6. We will be using this, like I said, to solve very easy questions later. So you need to understand the concept we are using right now. So I'm going to teach you this, but yet I will also teach you another thing. How to solve this. Okay, we'll learn how to solve this so that when you don't have any binomial expressions, you can still work it. But we are dealing with the FOIL method first. So the FOIL method says that what? First terms will multiply themselves. Look at first term in the first binomial expression, then the first term in the second binomial expression. Then multiply them together. Put your answer down. Then go to outer terms. The outer term, that is the extreme left term in the first, and the extreme term on the right are the outer terms in the two expressions. Then you multiply them and put your answer down. Then you take the inner terms following the FOIL. Inner terms. Inner term stands for the terms that are inside, and it is the middle terms. Okay, the one that is in the middle. Okay, so that is that. Then finally the last terms. Okay, the last terms in each expression. Okay, so that gives us this answer. Okay, so that is that. Okay, so let's go and solve the second one. Then I'll come and show you another way of solving this, where you distribute them over. So once again, FOIL, first terms, outer terms, inner terms, and last terms. So x times 2 negative 2t we get negative 2tx. Or let's say xt. It's okay. Sorry. Negative 2xt. Okay. Then second. Oh, sorry, we didn't do the right thing. We didn't do the inner terms first. We didn't do the first terms. The first term is x times 2s. So 2sx. Okay, that is the first one. Then minus 2tx. Okay, then we go to the 2 times, that is the inner terms. 2 times 2 is 4ys, so we get 4ys. Then we'll go to 2y times negative 2t, which are the last terms, minus 4ty. Okay, so it's simple and very straightforward so far as you know your FOIL method, but multiply them gradually. Be careful with negatives, okay, because it might get you wrong answers. Okay, so that is what you're going to do. Now let's work in a different way. We are not using the FOIL method now. Now we are going to use a method which distributes them. So anytime you are giving this thing, let the first term multiply everything in the parentheses of the second. So a times a plus 3. You've done for the first one, okay? Then whatever sign follows the second one, bring that sign. So plus 2 for the second number. A plus 3. That is it. Do you get that? So remember the FOIL method, which is good. The reason why we are doing that is we'll use it some time to come, and it will help you a lot. So I'll remind you of the FOIL method later. That's why I brought that in. But if you are solving this is the simplest way as well. So it doesn't matter if there are 3 terms in an expression. Although we are doing binomial, you are fine for now. Although we are doing binomial, you are fine for now. But if it's not binomial, you use the same way to work. Okay, so the first one will multiply everything in the second parenthesis plus the second one. So whatever sign divide them will move in that way. So your answer will now be, when you move on, let's take that you go here, you get a squared, because you are opening this, right? This will go there. So a squared plus what? 3a. But there is a plus, so you bring your plus again. 2 times a will be 2a plus 6. Okay, so you can write it on a straight line. That is fine. It's the same thing. So you have this and that to add. So you get a squared plus 5a plus 6, just like we did the other one. Okay, so that is what you do. Okay, you can write it in a straight line so that it will be easier for you. Okay, let's do for the second one too and see. The second one too is like that. Like I said, write the first one, take them one by one, and let each of them distribute each of them on both of them here, both of the second one. So you get x into 2s minus 2t. Okay, if you like, continue with your second one, plus 2y, because you are taking the first one to distribute over the second one, is the same as 2s minus 2t. You get it? So you will be expanding. You will now get 2sx, right, and minus 2tx, then plus 4sy, 4sy minus 4ty. Okay, then you look for common terms. This is sx. Is there any other sx? No. tx. Is there any other tx? No. Sy, no sy. So there are no like terms. So you leave it like that. You are done with this. Did you get that? So in case you are given more than 3 things, all you have to do is to do the same thing. So we are still under binomial, but we are tackling this once and for all. So don't be confused. We are just bringing in new terms. It doesn't mean they are binomial. These examples are not the new ones I'm bringing in are not binomials. Okay, the new ones I'm bringing are not binomials, but we'll use them to just explain the way I was advising you to solve the new one. Okay, so let's take it that we have something like a plus b into e plus f plus g. So this time around it's not binomial, like I said, just to explain. So you are going to distribute a onto all of this. So you get a into e plus f plus g. Then you come to b plus b, because after the a you go to b plus b, and you do the same thing, e plus f plus g. So this is a standard way you can work any multiplying any expressions together. Okay, so you are going to get ae plus af plus ag plus be plus bf plus bg. That is it. There are no like terms, so you leave it like that. But I'm just teaching you how to distribute them. Okay, I'm just teaching you. So what I'm saying is, anytime you are giving stuff like that, anytime you are giving expressions to multiply, take the first expression and the terms in the first expression one by one, and let them multiply everything in the second expression. Okay, so let them multiply everything in the second expression. So, but because we'll be needing that strategy of working for binomial expressions, especially when we are working on factorization, that is why I taught you this new one. So we'll learn more with time. Okay, I just talked to you about multiplication of other algebraic expressions, but we would repeat it again. So you see what we have here. So your a, so you have your a in the first expression. Okay, your a, then you bring everything in the second expression, b plus u minus n. Okay, then you see what is the next thing is plus b, plus c. Then you bring the same thing, u b plus u minus n. Okay, as simple as that. Then you now start expanding. A times this, a times that, a times that, b times this, b times that, b times that. Okay, so it is ab plus au minus an. Okay, because there's a negative here, plus cb plus cu minus cn. Okay, as simple as that. Look through if there are like terms, do your additions and subtractions, and leave the terms that could not do anything to themselves. So that is it for the second part. So now we are going to talk about division on binomials. Okay, and we use the same division on any other expressions, but for now let's talk about binomials. Normally I would want to write division in a way I understand better. Okay, so this can be written as 4xy plus y, okay, all divided by 8z plus 4. Okay, so that it's more understandable. Please, you know this bar is under all of them, so this is treated as one number. The numerator is treated as a single number, so you cannot divide individual numbers out of that. And this is an expression. You don't divide. Expression come as one, so you cannot divide individuals. Okay, you can divide terms, and terms are factors. when there are only terms and there is no expression. Okay, so the best way you can do this is to what? Factorize the best as you can. Try factorizing to see if you have common factors among the numerator and the denominator. So here we have y on both sides, right? So we bring y outside. So we are doing factorization of this. Factorization means that break the number or the expression into factors. Okay, so you look out for a common variable in all the terms, or a common number in all the terms. So the common number we find in the terms is there's y here, there's y here. So we bring the y out. Y will go through, we get 4x plus y will go here 1 plus 1. Okay, then here we have 8z plus 4. 4 is a common factor to 4 itself and the 8. So we bring 4 out here. We have what? 2z plus what? 1, because 4 into 4 is 1. That is it, because there is no factor. 4 cannot divide y. 4x plus this cannot divide. So we leave it like that. Okay, so that is how we solve a thing like that. So when it comes to division, always look out for common factors and just make sure you factorize them. Now you have two numbers. It's one term though, but they have two factors. This is one factor, this is the second factor. This one to this one factor, this is the second factor. So if they have common factors, you can cancel them out. That is the only time you can divide through an expression. It is when you have factors dividing factors, whether single factors or factors in expression which are the same. Okay, now let's delve into quadratic expressions. So we've been able to work with expressions and we are understanding expression with time. So an expression is just a mathematical phrase, okay, an incomplete sentence. But we have different types of expressions. We've talked about binomial, where there are only two terms in the expression. Okay, and now we are talking about quadratic expression. Quadratic expression comes in the form ax squared plus bx plus c, where a, b, and c are constants. Ax squared plus bx plus c, where a, b, and c are constants. Okay, so let's see how they work. But a cannot be equal to 0. When a is equal to 0, it's no longer a quadratic expression. Okay, it is only a quadratic expression when a is not equal to 0. It can be any number, it can be a fraction, it can be a negative number. But what you need to bear in mind is that there must be x squared term. So the coefficient of x squared is the a, and the coefficient of x is the b, and c is actually a constant, which also is a coefficient of x raised to the power 0. We all know that x raised to the power 0 is what? 1, like we did in our indices, but we don't want to go there. Let's keep it like this for now. So this is the form you write your expressions. Okay, this will also take us a long way when it comes to writing the formula or working with tables, okay, or mapping, but we'll not go there yet. So please, let's pay attention as we continue with this. Okay, so I am taking this over again, okay, and I'm going to do them step by step. We are still using the grouping method, okay, and the grouping method, like we were told, with the grouping method, what we are going to do is, first of all, find the product of A and C. please, you can go back and watch the form of quadratic expression. Okay, it is ax squared plus bx plus c. So a is the coefficient of the x squared, whereas b is the coefficient of x and c is the constant itself. But we are finding the product of a and c, but a is 1 and c is what? -6 from the question or the expression that we have here. So our answer will give us what? -6. That's the first step. The second step is find two factors of the product of AC, which is this one. Find two factors that when added or their sum will give you B. Okay, so you are finding two factors that when you add, you will get the coefficient of the second term, which is B, or coefficient of X, which in the general formula, in the form, the quadratic form, it is B. Okay, so what are the factors? The factors will be what? -2 and 3. So -2 and 3, when you multiply, you are going to get your -6 because they are the factors of -6. And when you add them, you should get 1 because 1 is the coefficient, which is the B, coefficient of X. So our third thing to do now is, after finding the factors, rewrite the expression. Replacing the factors of AC with, replacing B with the factors of AC. Okay, so that is what we will do next. And so we are going to do that. So we write x squared. Now we have -2 and 3. So -2x plus 3x. Then we'll bring our -6. So this is just what we changed. This is what we brought in. Okay, we changed them and it's the same as x. Then our next step is to now group these things and factorize them. I will not do anything. I will just go straight forward and take them first two, then second two. So the first two, I look for a common factor among the first two, which is x. So there's x here, there's x here. So I bring x out here. Then I open a parenthesis. Then x goes into x squared, x. Then x goes into -2x, -2. Okay, I'm done with that one. Then I come to the second one. What is a common factor here? It is 3. So plus 3. Then I open a parenthesis. 3 goes into 3x is x. 3 goes into -6 is -2. Okay, so now you realize that we have the same factors in brackets. So it means that we are going to break them as one of the factors. Then the one outside will just come out. So x plus 3 is one factor, and the second factor is what? X minus 2. Okay, So that is how we use the grouping to solve for or to factorize our quadratic expressions. Okay, is that okay? That is fine. So we are now going to use the reverse FOIL method. Let's see that too. So we are done with this. We are now going to use the reverse FOIL method. But quickly, let me remind you how the FOIL method is used so that it's easy to find the reverse FOIL method. So let's take it that we have A plus B, and we have maybe A plus C. Okay, the FOIL method says that the first terms will multiply. So the first terms will give us A squared, and the first and the last, okay, which are the outer terms, that's the O, will be AC. Then we'll get BA, or AC, sorry. Then we'll get BA. Let me just write it well. AC, then we'll get BA, then we'll get BC. So that is the FOIL method, okay? That is the FOIL method. First terms multiply. So let's write our FOIL down so that it will be visible. First terms will multiply. So first term. That is what we get here, right? Then, so at the end of the day, we realize that our answer, the first term will be only first terms multiply, and the last term will be only last terms multiplying. You get that? The first term will be only first terms multiplying, and the last term will be only last terms multiplying, because only F and L will be working. So that is how we are going to solve. We are going to factorize this. Very easy. Let me take it again. First terms will be only first terms multiplying. That is first term here and first term there in the two parentheses or two expressions, binomial expressions. And the last terms will be only the last terms multiplying, the B and the C. That will give you an answer direct. You don't do anything to them. Don't worry about the middle term for now. We'll know how to handle them with time. Okay, so now we are going to use this reverse FOIL method. So immediately you see a question like that, please, this time around you are going this way. You remember that first terms will multiply to give you this, so it will be x times x, right? Because first term multiply to give us that, so it will be x times x. Then the last terms will also multiply to give us the 6. The last terms, what will give you 6 here? It will be 2 and 3, right? What will give you, so you find factors of this that will multiply to give you the last term. So it will be negative 2 and 3, or 2 and negative 3, or 1 and 6, or negative 1 and 6, right? But remember that there is a middle term that you need to work with. So the middle term should be a sum of the two. So you realize that your answer should be negative 2 and 3. Let me take the last part again. I think that is a bit confusing. So first, after doing this, you know that first terms will give you the first thing here. So first terms should be the same thing. To get x squared, to be x times x. I hope that is clear. To get the first term is x times x. So that is correct. Now we want the last term, because last terms will multiply to give us the last thing here. Okay, the last terms multiply to give us the BC. The B and the C multiply, and the B and the C will be the last terms. We don't assign any sign, negative or positive yet, but we realize that those two terms, they must also add to give us the middle term. Those two terms must add to give us the middle term. Those two terms must add to give us the middle term. Okay, so how we can do that is find the factors of the last term. The last term is negative 6 here. So since it's negative 6, Okay, since the last term is negative 6, we are just going to find factors. Negative 2 and 3 will give us negative 6. 3 and negative 2 will give us 2 and negative 3 will give us 6. Negative 1 and negative 6 will give us negative 6, and negative 6 and 1. But they must add to give us the middle term. Okay, so it is negative 2 and 3 that will give us that. So that is just what we do. We bring negative 2 here and we bring our 3 there. That is it. We factorize it. Very simple and straightforward. Do you get that? Very simple and straightforward. Definitely we'll have challenge with this as we move on, but we'll actually work on that. We'll sort that very easily. So let's move on. Okay, so we are going to work on a new question. This time around, you can see that A is not 1, it's 2. So this one will pose a little bit of a problem for us. But you will first use our grouping to solve it. So you remember the grouping. Our first thing we did was 1 is to find AC. That is multiply the coefficient of x squared by the constant. So AC is going to give us what? 2, right? Because it's 2 times 1. But okay, let me do it so people don't get confused. 2 times 1 which is equal to 2. Then the next thing we did was what? To find two factors that when we add, we are going to get two factors of the product here of this, that when we add, we are going to get the middle term. So you know the middle term is negative. It means that this should be negative 2 and negative 1. Okay, so negative 2 times negative 1 will give us what? The positive 2 that we got from the beginning. After that, we are going to rewrite our expression, replacing the negative 3 with the negative 2 and negative 1. Okay, so we are going to get 2x squared minus 2x minus x, because it's 1x, then plus 1. Okay, we just replace this with these new factors that we got. Then after doing that, our fourth step is now to group them. Okay, our fourth term, that is where the grouping comes in. So you can group them in any order. I will always take the first two and take the second two on their own. I'll treat them separately. So when I take the first two, I'll find common factors. The common factors among the first two is 2x, right? Then I open my parentheses. So 2x goes into 2x squared is x, and 2x goes into 2x is, you bring your negative sign. 2x goes into 2x is what? 1. Okay. Then you are left with negative x plus 1, right? So what's the common factor here? The common factor here is negative 1, because there's, it is 1, but because one of them is negative, you want to do negative 1 outside. So negative 1 goes into this, will be x, and here is negative 1. So you are going to get 2x, because these are the same. You get 2x minus 1 and x minus 1. Okay, so that is what you get for your answer. That is using the grouping method. Now let's come and use the reverse FOIL method. In this case, we have a coefficient of x squared, which is a cracking something, and we need to think hard. Okay, like we were told, bring your parentheses, because that one, we know what happens. We know the x squared, the 2x squared was multiplied by the first terms of the, because the 4, we multiply first term, so the result was gotten by multiplying the first terms. But so we get x here, x here. But when you multiply x and x, you are going to get what? X squared. But we have 2x squared. So there's something we need to do. Don't worry. Let's move on to our next thing. Okay. Now we are confused. We don't know what to do. So you've put it down. Okay. Because there's a coefficient, this is what you have to do of the x squared. What you are going to do is do what we were asked to do. Find a product. Before you continue, you find the product of AC. So the product of AC will be equal to what? 2, right? Right? So you find two numbers the same way you did this. You find two numbers that when you add, you get the coefficient of x, which is b. So the two numbers will be what? -2 and -1. Okay? So it's the same thing. You do the same things, but now after finding the two numbers, so we have -2 and -1. These are the numbers. Don't put them inside yet. Divide them by your coefficient and the coefficient of x squared. Divide them by coefficient of x squared. Just divide the two factors. So they are 2, -2 and -1. Then divide by the coefficient of x squared. So here you are going to get 1/1, right? And here you are going to get 1/2. Just put and multiply the denominator by the x squared. So this one will be 1 and it will be -1. Okay? And multiply the coefficient of here. So we get 2x minus 1. So it will be x minus 1, 2x minus 1. Let's take it again. Reverse FOIL method. What we were asked to do is what? Because when we were expanding, we just multiply first terms to get our first term here and multiply last term to get our last term here. We are going to do the same thing. So first of all, we'll just do this. Unfortunately for us, there is a coefficient here. So even if we put x here and we'll put x here, when we multiply the first terms, we are not going to get 2x squared. We only get x squared. So we don't know what to do next. So what we have to do is to go and apply some of the steps we applied here. The first two steps, only the first two steps. All we have to do is multiply a and c. And a and c are the coefficients of x squared and the constant c. Okay, so we are going to get 2 times 1, which will be 2. Then we need to find two factors. The two factors, after multiplying this, that when we add, we'll get the middle term. And the two factors are -2 and -1. Okay, so just come and write the -2 and -1 under each parenthesis. Now you are going to divide through by the coefficient of x squared. So you divide here by 2 and here by 2. It is the same thing. Just the factors you got, divide them by that. Okay. Then after dividing, you have to simplify anything if there is anything to divide through. So you divide, this will go here 1, this one will go here 1. Okay, and this one you cannot divide anything. So the first part goes here. The denominator of the first one will multiply the first one here. So this is 1x, but we don't have 1x, so we'll just leave that. It is just x. Then there is a -1 on top, so we bring the -1 here. The same thing here, we bring the 2 here, the denominator here to this one, so we get 2x. And there's a -1 here, so we get x minus 1, 2x minus 1. That is the same thing here, x minus 1, 2x minus 1. That's so interesting, right? So when there is a coefficient of x squared, don't worry, you can still use the reverse FOIL method, but you have to take just 2 more steps. That is, find AC, then do what? From the first one, you just found AC and found the factors. But this time around, after finding the factors, just divide it by the coefficient of x squared. Then you now write them in that order, simplify them into their simplest forms. Then now let the denominators do the multiplication of the first terms, and the numerators, whatever sign goes with them, you will just put them there that way. Okay, let's see our next example. So we are coming to solve for difference of two squares, and we are going to factorize difference of two squares, and this will be used in so many ways. Okay, so difference of two squares means that a squared number subtracting another squared number, or subtracting a squared number from another squared number. Okay, they could be variables, they could be numbers. So this is our example we are going to start with. Okay, x squared minus 4, but we are going to use the reverse FOIL method. Okay, we're going to use the reverse FOIL method. What did we say? We need to have our form in ax squared plus bx plus c, but we don't have bx, so b equals to 0, right? So so this is how it's supposed to be, and the c is the negative 4, so we can still work with it. So what we are going to do is we'll bring our parentheses open nicely. We know that x squared, that is that it will be the first terms multiplying to give you the x squared. Then the second, as we were told, is what? The last term, which is negative 4. Negative 4, we find two factors that when we add, we are going to get the middle term, which is the b. B is 0, so we'll be getting negative 2 and what? 2. So we just put negative 2 and 2. That is it. X minus 2, x plus 2. So that is difference of two squares. You know, difference of two squares is, so if you have a squared minus b squared is what? A plus b and a minus b. Okay, and that is how we proved it right now. Let me take it again. It's so simple and fun, right? So we are just doing it again. So difference of two squares is x squared minus 4. X squared is a squared something because x is squared, and the 4 is also two squares. But don't worry yourself thinking about even the numbers. Okay, what you need to know is just follow the reverse FOIL method. What do? We just bring our parentheses completely nicely here, then we bring our x's because they are the two that will multiply to give us the first thing. Lucky enough, there is no coefficient. If there was coefficients, we will know what to do, but there is no coefficient. Okay, so we just move on. Now we were told that we have to find two factors for the c to give us b. So here we see that b equals to 0, right? B equals to 0 because it is 0x. That is why there is no x there. So b equals to 0. So we have negative 4. We need two numbers that when we multiply, we get our negative 4. But when we add, we'll get 0. That is the b. So it is negative 2 times 2. Okay. So you just put them there. Negative 2 and another 2 plus 2. These two will give us negative 4. And when we add, we get the 0. So we put them in. So it is x minus 2, x plus 2. We have just proven difference of two squares. Okay. Okay, so let's even do it with a different question, where this time around, let's take a question like this. A squared minus b squared. Okay, so we'll do the same thing. If this is our first term, we'll just say a times a will give us the a squared, right? We understand. Then b, there is no c, and there's no what do you call it? There's no middle term. Okay, there is no middle term, and so because this is a constant, and so we want two numbers. When we multiply, we are going to get negative b squared, yet when we add, we are going to get 0. That is the b. Okay, so it's going to be what? B times negative b. Okay, we'll get negative b squared. So these are the factors. Just put them in, plus b and minus b. That is it. Okay, so we are done with that. Now let's do change of subject. Change of subject. Change of subject. And what does it mean? It's isolating one variable from all other variables and numbers. It is isolating one variable from all other variables and numbers. I have listed some steps we can take in doing this, but don't worry, as we move on, we'll know how to work with these steps. But let's quickly go through these steps. Expand all parentheses, so get everything off parentheses. Then you have to move or get rid of variables or numbers that have the weakest connection with the variable or item to be isolated. So you are taking some stuffs from one stuff. You are making one variable stand all by itself. So you'll be trying to get rid of everything around it. But first of all, you need to get rid of the ones that don't have very strong connection with them. Okay, so we will do them first before we move on to the ones that have strong connections. Then you follow math procedures to do those things that we said right now. Okay, so we continue. So this is our first example of change of subject. It says that what? Make x the subject of the equation given, and this equation will be meeting it because it's very familiar. It is y equals to mx plus c. That is the equation of a straight line. Okay, but this time around, maybe we are given all the values and we only need x. Okay, maybe we don't know the x value. So you are going to rearrange everything to get x standing at one place. So from our instruction, the first thing we said we'll be doing is what? We said the first thing is what? To get rid of. Okay, we said we have to first get rid of any parentheses, but we don't have any parentheses. But next thing is get rid of the variables or numbers that have the weakest connection to the letter to isolate. Okay, so we are taking the one that has the weakest connection. So let's just look at it. The y is already away, so it's not even close to it. But there is m and c. Which one is closer? It is the m. So and the c is weaker. So you take the c away. So the c will go like we did earlier on. You move the c to the other side. So you get y minus c equals to mx. So you see that you are now left with m and x alone. So gradually you are moving them, okay? But you only need x to stand alone. So what you do is you divide there by m and divide there by m. So you get x equals to what? Y minus c divided by m. Here, because x is on the positive side, we don't worry ourselves. But if x was on the negative side, you have to move it to the other side so that it will stand clear of negative signs. Because like I told you earlier on, we don't want to be dividing through with negative numbers. It can be tempting. We can even forget, or we can divide and may not be able to do the right thing. Okay, so that is for that. Wow. So this is another very serious one here, and what we are supposed to do is what? To make h the subject of this. Okay, now the question is, what do we do? Which one is the weakest link? Okay, this time around there is no much of a weakest link, because all of them are multiplying except the 3, which is dividing. Okay, so first of all, when you have problems with fractions, make sure you get rid of the fractions so that you have a straight line equation, that is equation devoid of fractions. Okay, so let me rewrite this so that you understand what I am saying. So v will be equal to 4 over 3 pi r squared height. Okay, that is the volume of, I can't even remember. So let's move on. So v equals to 4 over 3 pi r squared height. Okay, so we are making h the subject. So by, like I said, anytime you get a fractional equation, get rid of the fraction. Okay, so because it's only 3 here, you multiply here by 3 and you do the same thing too. You multiply here 2 by 3, so 3 will get rid of 3 here, so that you'll be having 3v is equal to 4 pi r squared height. Okay, as simple as that. Then now that you have everything multiplying the h, you just divide through by that. 4 pi r squared here to 4 pi r squared, cancel out, then you have h equals to 3v over 4 pi r squared. That is it. Very simple. Another interesting question here, and what we are supposed to do is to make h the subject. Okay, sorry, I did not write that. So make h the subject again. Okay, so for your information, this covers everything here. Okay, so it's not only on top of, it's on top of all of them. So we are going to make h the subject. Okay, but I mean, we have a problem here. There's a whole structure, that is the square root sign on this. But if you can remember our indices, if you don't, please go back and take care of that. Okay, if you can remember our indices, square root means half. So we're going to rewrite this by removing the square root sign and bringing the half. So we have 1 over n is equal to k squared plus p squared over hg all raised to the power 1 over 2. Okay, that is the meaning of square root sign. Okay, so we've gotten rid of that. So now that we want to make sure h stands alone, we have to get rid of the half there. So what we do is we multiply here by 2, and we do the same thing to this side. We multiply here by 2. Okay, so this will cancel the 2 out. So now we are going to have, if you remember our thing, you get 1 over n squared equal to, so you can go back to take care of our indices lessons. It's on our YouTube channel, so you can go and look at it again. You are going to have, sorry, this is p squared, let me keep it. So we have k squared plus p squared all over hg. Okay, now we were told that we need to get rid of all fractions. Okay, so it doesn't matter if that is even what we are making the subject, make sure you get rid of fractions. So we are going to get rid of the fraction here. So we are going to multiply through by hg. So 1 over n squared times hg is equal to k squared plus p squared over hg all times hg. Okay, so hg will cancel hg here. So we are left with 1 over n squared times hg equals to k squared plus p squared. You see that? But we still have another, what do you call it? Fraction. So we continue doing until we get rid of all fractions. This time around, this is now one thing on one side, just like we have this one here like this. Then we divide it. So we'll multiply everything here by n squared, and we'll multiply everything here by n squared. So n squared will cancel n squared. We have hg equals to k squared plus p squared times n squared. But we are looking for h, so we divide through by g. Divide through by g. So we get h equals to k squared plus p squared times n squared over g. Okay, as simple as that. It's long, but when you take your time and you work step by step, you get things done. Welcome back, and I'm happy by now you are understanding the various terms in algebra, so that when you start working, you are very okay. It is all fun. We'll still keep doing, and as we move on, we'll know what's more to learn about the algebra. But so far, we've taken care of some few areas that I think you are enjoying. So we'll continue. Like I said, algebra is broad, so we still have a lot to learn under that. But once again, follow us on Facebook, and go and like our page. Write your comments so far as this program is concerned. Instagram, Miggy Consult, YouTube, Miggy Consult, and also on YouTube, go and subscribe to our page and click on the notification button, so that anytime we put on new videos, you can watch them. You'll be alerted to watch them. Please, we need your input. We need to know that what we are doing, you like it, so that at the end of the day, we can also get the strength, the energy to do it, because when you like it, we also love it. Thank you for watching, and let's meet again on our next area. Thank you. Bye-bye.